All right, and welcome back. So today we are going to be continuing our discussion on direct variation, and we are going to be looking at slopes of several lines, and we're going to be able to interpret the slope of a line in some real world scenarios. We're then going to take it one step further, and we're going to be able to write equations that represent each line by knowing the slope and knowing and or recalling direct variation, which, as we recall, is y is equal to mx, where m is the slope. So without further ado, let's talk about working. Here we go. So on this slide is a graph comparing the salaries of servers at the Chili's and Applebee's. As we look at the key down here at the right, you can see the red line represents Chili's. Hi, welcome to Chili's. And the blue line represents Applebee's. The x-axis represents the hours worked, and the y-axis represents the earnings or the money that you generate as you work. So let's talk about a couple things that we notice here. So what are some things that you notice? Some things that I notice is that both of these lines are going through the origin. And well, that should make some kind of logical sense that they start going through the origin. The x-axis represents the number of hours that you work. The y-axis is representing how much money you earn. So if you don't work any hours, well, you don't get any money, right? That's kind of how life works. If you want to generate an income, you've got to put the work in, right? So they both start at the origin. But let's talk about comparing some of these salaries. Let's say you work 2 hours. Which job or which restaurant pays you the most amount of money? And how do you know? If you work 6 hours, which company pays you the most money? Or which restaurant, I should say, pays you the most money? Yeah, Chili's seems to have a much more better paying job, right? Now, obviously, this is not minimum wage, but servers typically don't earn minimum wage because they generate the tips that people leave. But as we look at it, let's start to interpret some things that we are noticing. We're seeing that Chili's seems to offer more money for a comparison of hours. We looked at, all right, well, how much money do we get at 2 hours? How much money do we get at 6 hours? So let's just do a rough little estimate. If we're looking at 2 hours worked, if two is our hours, that's on the x-axis, about how much money do you make? About. Well, our y-axis is going up by fives. This happens to be somewhere between the 5 and the 10. So let's just call this about $6. What about Chili's? If we look at 2 hours, well, we'll see we earn $10 for those 2 hours. We also spoke about 6 hours. Let's look at 6 hours worked. If we interpret our graph here, at 6 hours, Applebee's pays you $20. And Chili's gives you $30. So we're seeing that as we start to work more hours, this difference between the companies really starts to show. If we compare 2 hours, Chili's gave you $10, Applebee's gives you about $6, and that's a $4 difference. Then as you work more hours and you get to 6 hours, Chili's gives you $30 and Applebee's gives you $20. Now we're at a $10 difference. So as we continue to move forward, well, we're going to see that we're going to generate more money if we work at Chili's than if we work at Applebee's. So with this in mind, let's start to talk about some questions that we might want to answer. Where would you rather work and why? Explain your answer using evidence from the graph. I'm going to go back to the graph. Please answer this question. Again, the question is asking where would you rather work and why? All right, well, hopefully you said Chili's because they offer a higher salary. And you know this, or I know this, because the graph of their pay is steeper than Applebee's. It rises much more readily than Applebee's, right? It's going up more than it is at Applebee's. Let's try to find the slope of each line. So I'm going to ask that you find the slope of each line, the Chili's and the Applebee's. I'm going to go back to the graph to allow you to do that. Here you go. Try to find the slope of each line. Remember, slope is our change in y over the change in x. Hopefully, you were able to find that you get a slope of 5 for Chili's and a slope of 10 over 3 for Applebee's. All right, and the third question, what information does that slope tell you about working at each restaurant? Again, Chili's has a slope of 5, Applebee's has a slope of 10 over 3. What information does the slope tell you about working at each restaurant? Yeah, in the graph, the slope tells us the cost per hour. Chili's pays $5 per 1 hour, while Applebee's pays $10 per 3 hours, or about $3.33 for 1 hour. So if we were to try to write an equation based upon these, let's do that together. Let's try to figure out the equations. Well, as we recall, this is direct variation. It's a straight line. It's going through the origin. So it should be of the form y is equal to mx, again, where the m is our slope. So if we look at Chili's, what would be the equation for Chili's if we know the slope is 5? Yeah, it's going to be y is equal to 5x. And we got that from interpreting the graph. We said, oh, it pays $5 per hour. But what about Applebee's? What is going to be the equation for Applebee's here? Yeah, we're going to get y is equal, and you could either write 10 over 3, or you can write about 3.3, but I'm going to leave 10 over 3x. And we got that because you get paid $10 per every 3 hours. So that's how we're going to be writing equations. We're going to be trying to interpret the slope of the graph, and then we're going to be putting it into a direct variation equation. Knowing it goes through the origin, we can just write y is equal to mx and substitute in our slope. Awesome. Let's do 2 more examples. So let's try to interpret each slope here. On the left-hand side, titled car, the x-axis represents the gasoline in gallons. The y-axis represents the distance traveled in miles. So what we're going to do is we have to find the slope. Well, we know first off, we have to go through 0, 0, and we try to find another point. Well, I see we have a point right here. Well, the x-axis is 1, the y-axis is 25, so the coordinate point is 1, 25. If we go back to that Q-tip that we said before, if we know it's direct variation, well, then we know the slope. We look for that first coordinate point. Well, the first coordinate point that I see is 1, 25. It's going to be the y value on top of the x value. The y value here is 25. The x value is 1. So it's going to be 25 over 1, but we can simplify that to 25. And now we go into direct variation. How do we write in direct variation? It's y equals mx. Therefore, it's going to be y is equal to 25x. Awesome. With this in mind, try out the internet plan and try to figure out the slope for that and then the equation for it, and resume when you're ready. All right, so hopefully you have tried this out. And if you notice, they give us two coordinate points here. They give us the origin of 0, 0, and they give us the first coordinate point 1, 10. So if we're trying to calculate the slope, it's going to be the y value over the x value because it's direct variation and we know it's 0, 0. So we're going to get 10 over 1, which is just 10. And now we can take it and we can write it into direct variation. It's going to be y is equal to 10x. And the reason that we are able to write in direct variation with just one coordinate point, knowing it goes through the origin, is if we use the slope formula, it would be 10 minus 0 over 1 minus 0, which is 10 over 1, which is what we got over here. So by knowing it's direct variation, we're able to use that first coordinate point and put the y over the x. This isn't always going to work because soon we're going to be starting to see things that are not in direct variation. But for right now, this is a good Q-tip for you. So we get y is equal to 10x. Awesome job with this, folks. Keep up the great work. Really, really proud of you. If you have any questions, please jot them below. And I will be talking to you soon.